All right, let's get going with question 8, the circuit electricity question. We've got a circuit represented below. The battery has a EMF of 10 volts. There it's given in the circuit, and an unknown internal resistance, and so that's just labeled little r. We've got a voltmeter V1 connected across the battery and a voltmeter V2 connected across an open switch. There's our switch that's open. All right, 8.1. What's the reading on V1? Now remember, V1's connected over the battery. Our switch is open, and because the switch is open, it means that there's no current flowing. And if there's no current flowing, if I is 0, then a voltmeter over the EMF is simply, a voltmeter over the battery will simply read the EMF because current isn't flowing, and therefore there are no lost volts. And so if V1's reading the EMF, it's just reading 10 volts. 8.2, a voltmeter over an open switch. Relatively arbitrary question, but if there's an open switch, there's no current flowing, obviously. And so if you trace the ends of V2 back, you effectively simply have another voltmeter across the battery, in which case V2 is also reading 10 volts. If we close the switch and current is flowing, then we've got a voltmeter simply connected over a piece of wire, and there's no change in potential as the charges flow through that. And so if we close switch S, then V2 would read 0. All right, 8.3, switch S is closed and the reading on V1 drops to 7.5. So what that is showing us is that 2.5 volts is lost. We call that lost volts inside the battery as the charges flow through it. Calculate the effective resistance of the external circuit. Now if we consider the external circuit, we've got 2 resistors in parallel. So we need to calculate their resistance first, and then we have 1 resistor connected in series, and so we're going to need to add those together. Let's start with our parallel combination. 1 over R parallel is 1 over 3 plus 1 over 6. That gives us 3 over 6. And so R parallel, if you invert that, gives us 6 over 3, which is 2 ohms. So the resistance of our parallel resistors is 2 ohms. So the total resistance then is the parallel resistors added to the 1 resistor in series, and so that's 2 plus 1 gives us an effective resistance of the internal circuit of 3 ohms. The reading on the ammeter, notice that the ammeter is connected in the main branch of the circuit, and as the current flows through that ammeter, it's then reading the total current. So the ammeter there reads the total current, and so we're applying Ohm's law. We're looking for I total is V total over R total. I is V over R. I put the subscripts in there just to remind us that we need the total voltage of the external circuit, total resistance of the external circuit. So the total voltage is 7.5. That was the reading on V1. The total resistance is 3. We've just calculated that, and so that gives us a total current of 2.5 amps. All right, calculate the internal resistance of the battery. That's little r. And our formula from the data books, EMF is I total current, and then in brackets total resistance plus internal resistance. EMF's 10, total current is 2.5, total resistance is 3, and so we're solving for little r, which turns out to be 1 ohm. Right, 834, if the 3 ohm resistor burns out, what will happen to the reading on V1? These are quite common questions. It doesn't ask you to do any calculations.